Deep within a distant galaxy, a star shines with a brightness hundreds of thousands of times greater than the sun's radiance. It is like a cosmic monster, a colossus that exhausts itself, ejecting streams of matter and light. Scientists hold their breath, observing its slow and painful demise. What is happening inside this celestial behemoth, whose instability threatens a blast powerful enough to shake the entire galaxy? Its fate is sealed, but what will the finale be? A supernova burst capable of illuminating space for millions of light years, or the birth of a new black hole, devouring everything around it? There are more questions than answers, but one thing is clear. This star is rewriting the rules of the game. Want to learn how giant stars shape galaxies and what fate awaits this star? Subscribe and hit the like button. The most exciting is yet to come. WOH G64 is the brightest red supergiant in the mid-infrared range in the Large Magellanic Cloud, located 163,078 light-years away from the Sun. The star is losing mass at a high rate of 10 to the negative fourth power solar masses per year. Observations have shown that there is an elongated emission zone around the star, with its major and minor axes reaching approximately 13 and 9 stellar radii. The star's own radius is estimated to be 1,730 solar radii, but it does not appear as a point source due to dust obscuration. This shape of the emission zone can be explained by bipolar outflows of matter or the influence of an unseen companion. Additionally, a dust torus is observed around WOH G64, whose brightness is 400 times lower than the luminosity of the star itself. An important detail was revealed when analyzing data collected since 2003. From December 2009 to 2016, hot dust began to form near the star, condensing at a temperature of 1500 Kelvin. During the period from 2005 to 2007, this phenomenon was not observed. Similar behavior was previously recorded for Betelgeuse, allowing for parallels to be drawn regarding the behavior of massive supergiants. How do red supergiants form, and why are they considered the final stage in the life of massive stars? Red supergiants form as a result of the evolution of massive stars and represent a late stage in their existence. When the core of a massive star begins to collapse, the temperature rises, initiating the helium fusion process. This rapid fusion leads to the destabilization of the star, causing a tremendous amount of energy to expel its outer layers. Thus begins a new phase in the star's life, the transformation into a red supergiant. At this stage, gravitational forces come back into equilibrium, but the star loses a significant portion of its mass. What is the key difference between red supergiants and hypergiants, and why does it determine their fate in the universe? Red supergiants and hypergiants represent different categories of stars, distinguished by their mass, luminosity, and lifespan. Red supergiants are massive stars that have left the main sequence, belonging to spectral class K or M and luminosity class I. They have radii ranging from 200 to 1500 times the radius of the Sun and low effective temperatures, 3000 to 5000 Kelvin. The luminosity of such stars can reach up to 500,000 times that of the Sun, and their stage lasts from 10 to 100 million years. Hypergiants, on the other hand, are even more massive and luminous stars with luminosity class 0 on the Hertzsprung-Russell diagram. Their mass can reach 100 to 120 solar masses or more, up to 200 to 250 solar masses. Luminosity can exceed 500,000, and sometimes it reaches millions of solar luminosities. The surface temperature of hypergiants ranges from 3,200 Kelvin to over 35,000 Kelvin, and their lifespan is extremely short, on average 1 to 2, at most a few million years. What will happen to the star, WOH G64? Will it become a supernova or turn into a black hole? Earlier, astronomers believed that a telescope with a diameter of at least 100 meters was necessary to obtain a clear image of a star located at a considerable distance from Earth. However, Specialists from the European Southern Observatory, ESO, managed to disprove this notion by combining data from 4 1.8-meter telescopes into a single image. As part of the experiment, astronomers succeeded in capturing the inner circumstellar region of the star WOH G64 beyond the Milky Way for the first time using the VLTIGRAVITY instrument at a wavelength of 2.0 to 2.45 micrometers. According to Keiichi Onaka, an astronomer from Andres Bello University, WOH G64 presents a rare opportunity to study the processes occurring in massive stars just before they transform into supernovae. In astronomical terms, just before can refer to a time span ranging from 10,000 to 100,000 years. Despite this, scientists believe that the likelihood of a supernova explosion for WOH G64 is quite high. The primary argument in favor of its imminent demise is the noticeable decrease in its brightness compared to previous observations. Onaka notes that the star has likely been ejecting increasing amounts of matter over the past decades, leading to its gradual dimming. While such a process may be temporary, in most cases, stars that have begun to lose brightness do not return to their original state. Supergiant stars like WOH G64 play a key role in the evolution of galaxies. They create and distribute heavy elements that become the building blocks for new stars and planets. The supernova explosions that conclude the life cycle of such stars not only enrich the surrounding space, but also generate shock waves that contribute to the formation of new star systems. Thus, despite their destructive power, giants serve as cosmic forges where the elements necessary for life are born. Want to learn more about how giant stars change the universe? Subscribe to the channel and stay updated.